So we talked about handbrakes. 3 different types. What are the 3 different types of handbrakes?
Vertical circle.
Vertical wheel,
And ratchet.
lever ratchet, horizontal,
Nope.
step brake. Okay, 3 types. B end of car. What the heck are we talking about? All cars have an A end and a B end. Okay, A end and a B end. Locomotives have front and back. Okay, front end and a back end. You have to be able to identify the B end of a car because sometimes you have to identify specific axles or wheels. And we count them from we number them from a specified direction, which always starts at the B end of the car. Okay? And you say, well, why do I care about that? If you have a defect on a car en route, we've talked a little bit about trackside warning detectors and how they inspect your train, right? If you let's say you get a hot box, a bearing that's hot, and you had to set that car out. So you get it set out of your train, you have to report that to the train dispatcher or mechanical folks. They're going to want to know which bearing is hot. Because when they come out, sometimes it might not be for 2 days. Obviously, it's not going to be hot anymore. So they need to know which bearing is hot so they can annotate it. You have to be able to identify that, and this is how you do it. I'm going to just kind of tell you how to do it, and then we'll go through the slides. Because it's pretty simple. The B end of a car is the end of the car where the handbrake is located, unless otherwise identified. And here's what they mean. This car here is a conventional car. Just like, you know, it could be a hopper car, box car, flat car, just a conventional one-platform car. Okay. We also have what we call intermodal equipment or multi-platform cars. Okay. This is all one car, but you happen to have 5 different platforms on it. Okay. We have other cars where you might have 2 or 3, 4. Doesn't matter. Okay. The reason they say unless otherwise identified, I got one handbrake on this car. For this big 5-pack stack car, it's more than likely going to have a handbrake on both ends. So I can't just look at the end where the handbrake is and say that's the B end, right? There has to be another way. So here's how we do this. To identify the B end of a car, I'm going to face the handbrake, the end of the car where the handbrake is. Okay? So if this is the back side of my car, that's the handbrake. Okay? All I got to do is face the brake, and then I count axles closest to me and go away. 1, 2, 3, 4. That's how simple that is. If I want to know exactly which wheel to identify, I will do this. Let's say I got a problem with that wheel. Face the B end, Then my left's my left, my right's my right, okay? This is on the right side. I would go 1, 2, 3. That would be the R3. That's how you identify it, okay? If it was on the left side, it would be the L3. So it's really simple. When the maintenance, mechanical maintenance folks come out, they know it's the R3, they know to go right to that wheel and do what they need to do. Okay? That's how you report that. Now let's talk about a multi-platform car. I have to identify the B end. Well, you got a big long car like this, you got a brake on both ends, right? How do I do it? It's really simple. The platforms on these cars are stenciled. Okay? One end of that is always going to be an A, and the other end's always going to be a B. Always. And then they're just going to fill in the blanks. C, D, E. Or if it's just a 3-pack stack, right? It would be A, B, and the middle car would be C. Does that make sense to you? So which car do you think's the B end? The one with the stencil B, right?
Oh, it literally just says B on it?
Yeah.
Oh, okay.
It's got the letter A or the letter B, C, D, E, just like that. So look at the car with the stencil B on it. That's the B end of the car. So face the B end and count just the way you did here. Now, there's one small caveat to this. Obviously, you got more than 4 axles, right? So we're going to count. This is just telling you everything I already told you. I'm going to get to the multi-platform. This is how you count the multi-platform cars. You identify the B end. Okay, so I'm up here facing it. Your left is your left, your right is your right. And just start counting just like you did on the regular car. 1, 2, 3, 4, 5, 6, all the way up, right? The only difference is when you get to the 10th axle, it's not called L10. It's called LZ. And then you start counting backwards on the alphabet. LZ, LY, LX. Why? I knew that was coming. And I don't know.
Oh.
Here's my guess. I mean, I don't know why they decided to do it that way. But here's my guess. In all these cars in the computer system, the car data computer system, and this is my assumption, and I could probably find out if I was that motivated, but I'm assuming that the codes here are only good for 1 digit. You understand? Like, like you can't put a 2-digit code in there, like 10. But I might take it upon myself to actually find out one of these days, but I think that's probably it. But now you see how that works though? 10th axle, it's LZ, and then LY, LX. Okay. Questions on the B end?
So anything more than one car will always have a stencil?
Yeah. Well, no. No. You might have a couple of flat cars that are together. They may not be stenciled. They're still a multi-platform car.
I should have said with 2 brakes on.
Right. Now if I get a 3-packer like this, all 3 of them will always be stenciled. All right. And there's still probably only going to be 1 brake, but they're still stenciled. Okay. But you get a couple of these flat cars here and there, you got 2 platforms together, they won't be stenciled, but they won't have more than 1 brake anyway. Okay. All right. Here's the reason why we're doing this, by the way. We're doing this to identify the wheel numbers or bearings that might be hot, okay? This is in your, this is an excerpt from your SSI, so turn to it.
Page 5.
If you haven't started on your homework for this, there's a lot of questions on your homework, I think, will have you use this table. All this is a, it's equipment table, and it covers multi-platform equipment, okay? Multi-platform equipment. I want to get you kind of thinking my way on multi-platform equipment. I usually don't say that term. I usually say intermodal equipment, okay? So if I do say that, that's what I'm talking about, intermodal equipment. So I don't want you to get confused, because a lot of us railroaders have our own little terms that we use, okay? So this kind of breaks down the various intermodal equipment that we have, or multi-platform. And you can see how it's set up. It goes car kind codes. That's what kind of car it is, okay? QY. Now if you see this car on a train list, your train list, and you will see this next week, your train list has a column for the type of car you're carrying, right? If this car would happen to be on your train list, it would not be a 2-digit car kind code. All the car kind codes on the train list are 3 digits for all cars, okay? So this car would probably look like, on a train list, it would say QY5. Why? Because it's a 5-pack car, okay? Something like that. But what is it? Well, it's a double stack. How many units or segments? It's 5. Total length, 308. Axle count, 12. Control valves, it's got 3. What does it carry? Containers, trailers, or both? This carries containers. Now you say, well, why do I really care about all the axle counts and control valves and length? Every one of those figures are extremely important. Think about this. Let's say your train right now is 5,900 feet. Okay? That's your train length. And the train dispatcher calls you over the radio, and he says, yeah, NARS 1, 2, 3, 4, I want you to stop up there at that siding. I want you to pick up that car. It's been repaired, right? And that car is a 5-pack stack car. You don't really have a whole lot of information about that car, right? So if you don't keep track of the fact that that car is 308 feet, now your train's going to be 200 plus, right? 6208 in the footage. But if you don't realize that, the next siding you go into, it might be 6,000 feet. And you're like, well, we should have fit. We're only 5,900 feet. You see what I'm saying? So these lengths, these axle counts, they do matter. Okay? Here's the thing with the axle count. Right here. That figure, 12. As a conductor, you have to know exactly how many axles are on your train. When you go over these detectors out there that inspect your train, they talk to you, right? You go over a detector, it says something like this. Milepost detector 186.3. No defects. axle count, 2, 8, 6, train speed, so forth and so on, right? When they give you that axle count on that detector readoff, you need to compare it to your train list. And if it's wrong, if your train list doesn't match that, what do you think you're gonna have to do?
Get out there and count.
You're gonna have to get out there, get on the ground, and go figure out what's going on. So that can be a pain in the rear end, right? Maybe it says you have 4 more axles than your train list does. Maybe your train list says 282. It told you 286. What's that immediately tell you?
You got another car.
You got an extra car. What if that car is some kind of heavy-duty hazmat car? Sulfuric acid, chlorine, some major explosive car, right? And you don't have the proper documentation for it. You see what I'm saying? It's important to know what's in your train. Okay? So if you go pick up this 5-pack stack car and you don't take into account, oh yeah, I need to add 12 axles to my axle count, you might be making yourself do a lot of excess, unnecessary work. You see what I'm saying? Because you didn't take care of it to start with. Control valves? We know what a control valve is, right? We say, well, why do we care? Here's why you care. We have this figure we compute on trains. It's called tons per operative brake. Okay? And what that is, it's a figure that the engineer figures, and it gives him an idea about the stopping power of that train based on how heavy it is. Okay? And the way you figure that is you figure total weight of the train, let's say 10,000 tons to make it easy, right? Divided by the number of control valves in the train. Okay? So let's say you got 100 control valves in the train and you weigh 10,000 pounds, 10,000 tons. Your tons per operative brake will be 100. That gives the engineer an idea about the stopping capability of that train. Is it going to take him forever to get stopped? Is it not? You see what I'm saying? Also, in your timetables, if your tons per operative brake are high enough, that could reduce your max authorized speed. So there's a reason why all this information is there for you. And we'll dig more into that as we go.
So these will, like, you'll get this chart in your bulletin?
No,
You'll get it in your train.
that chart you're just going to have in your SSI.
Oh, so this is just per, like,
This is general in nature about all multi-platform equipment.
okay.
All right.
So you will have this.
Oh yeah, you'll have that. But listen, here's the good news story. You don't have to figure all this stuff by hand. 99.9% of the time it's figured for you. Okay? The only time you need to really figure stuff is when you're out on the road. Because when you get your train list, it's all figured for you. Tells you how many axles you got, tells you how heavy you are, it tells you everything you need to know. Okay? Tells you your tons per operative brake, it figures that for you. So the only time you need to do this stuff is when you make changes out in the field. Because obviously you don't have a new train list to figure it for you.
If the detector gives you like an odd axle count, is that something that, like, you obviously wouldn't stop your train and go count, like, if it says like you have 263 axles rather than 264, like, is that just saying it's probably broken, or?
The dispatcher's probably gonna make the determination on whether he wants you to stop or not. But yeah, that's happened before. Okay.
That's what I was wondering, like, what happens if he gave you a number that was lower than what your sheet got, or gave you. Like, you didn't pick any more cars up or anything. Your sheet says 270 and it tells you 266. You're missing a car. And you go out there.
That means
you
your
have to
train
count.
list
Is wrong,
is wrong.
but, so,
You have to walk your train and figure out what's going on.
so if you are actually missing that car,
If that car, if you figure out which car is missing, you've got, you know, let's say you got car X, Y, Z, 1, 2, 3, 4, and you're like, well, I don't see this car on my train. All you would do is pencil out that car and refigure your train list.
okay.
Okay.
You wouldn't have to go find it. or,
No,
like,
no.
If you're on the main. for example.
Right, no. That happens quite a bit too, by the way.
Okay.
Because listen, these computers do all of our thinking for us, right? But they're only as good as the information we put in them. Okay? So if someone, I call it fat fingers a key on the computer, and he moves this car in the computer to this track by accident, well, when he makes a train list on this track, that fictitious car is showing up in there and it's gonna be on your train list. Now, they're supposed to be checking these train lists before you get there on duty, but a lot of times that don't happen. Okay. That's common too. I mean, that happens a lot. We don't like for it to happen, but it does. All right. When it comes to multi-platform cars, we usually talk about two different types. They're either articulated or non-articulated. This is what an articulated multi-platform car is. So Bruce, can you read it to us?
A car with multiple units, segments that have articulated couplings in which the units share a common truck.
As you can see on this car, each platform, the end of each platform, shares that one truck, right? That's called an articulated platform, okay? Articulated car. You know what that means, really? That's a very smooth riding car. Because there's no in and out, slack. You remember how Jeremy was telling you yesterday at the hump, how that guy could not pull the pin unless the cars were bunched up, right? Or if they were stretched out, he couldn't pull the pin. Well, the platforms in these cars, they don't have any slack. They don't move because they're all bolted together, okay? So it makes for a very smooth riding train. Imagine if you're on one of these trains that they were humping, nasty manifest train with all kind of cars, going across the countryside like this, right? It's called undulating territory. And so all these cars on this side of the hill, they start bunching in, and they start pulling out on this hill and bunching in. It's a good way to tear your train in half. You see what I'm saying? You don't have that problem with these cars. So these are articulated cars, okay? See, that's the truck, and that's the end of one car, end of the other car. Non-articulated.
Just a second. Non-articulated multi-platform car. A car with multiple units, segments, that are connected with solid drawbars. Each unit is a standalone unit and does not share a common truck with another unit.
Okay, we got articulated, non-articulated. Articulated shares a common truck. These have their own trucks. And you can see how this works. That's the end of that car, that's the end of that car. And they have their own trucks, okay? Now there's still multi-platform cars. You can see the solid drawbar through there. They don't come apart, okay? So They're still multi-platform cars. And they still ride pretty good too. I mean, there's not much slack. We call that slack, by the way. The in and out motion of cars and train. And there's hardly any slack in these either, you know. This is just an example of some different car types. That's a 3-pack stacker. 190 feet. They measure that from knuckle to knuckle. 8 axles, 2 control valves. And you say, well, how are they getting 2 control valves if it's 3 platforms? Somebody was probably wondering out of that. Here's the way they figure control valves on multi-platform equipment. They take the number of platforms and they divide it by 2, then round up. Okay, so if I got 3 platforms, I divide that by 2, that'll be 1.5, just round up. Okay, or 1.5, is that right?
Mm-hmm.
Yeah. And just round up. So that's how they get 2. So if I've got 5 platforms, how many control valves? 3, right? 5 divided by 2 is 2.5. Round it up to 3. Just another take on cars. Now, are these articulated or non-articulated? Answer was there. Hope you sell that. I asked somebody something like that on another class I had, and it was like a really good question. I was going to get them good, you know. And I didn't realize that what I was asking them, the answer was like right at the top at the time. And everybody was like, oh, that's a whatever that thing was. And I'm like,
How do you know that?
and you guys are sharp. And everybody's like, pointing up to it for me. So I look like an idiot. So, but you can see how these cars have their own truck. Right there. This is still all together. You can't get them apart now. That's all one car. Single. All right, knuckle types. You'll need to know these. Real simple though. We have essentially 3 basic types of knuckles. When I say knuckle, you know what I mean, right? The part on the end of the car that connects to the other car. Okay, weighs about 75 pounds. You'll get a chance to change them out in the field. Change one. We have a type E, type F, and a type H. Type E is the most common knuckle we have. Now, throughout your tenure on the railroad, you're probably going to see a lot of either one, E or F. You probably won't see hardly any H's, if at all. E and an F. So when you take your trips out there as a conductor on a road trip, I told you need to make sure you got an air wrench, make sure you got an air hose, all your flags, fusees, all those things. You also need to make sure you got 2 spare knuckles on your engine. An E knuckle and an F knuckle. Because if you break one en route, they're not interchangeable. So you got to have one of each. So the big takeaway is this, the 3 types and the most common type, right there. That's what you need to know. And as time goes along, you'll get used to seeing the knuckles, and you can kind of look at them and tell the different knuckles. Okay? See how this, the F is a lot square on the corner, this is round. But in any event, all the knuckles are stamped right here. That's how you're going to tell what the knuckle is. Okay? So if you're rolling down the track, and you can look at this too when you get up, take a break. When you're rolling down the track, you break a knuckle, you walk back there, yep, you broke a knuckle. All you gotta do is look at the top part of the knuckle right there, and you know that's the knuckle you need to get back there and change it out. Okay? Because if it's an E knuckle that broke and you take an F knuckle back there, it won't fit.
Do they usually want you to police up your stuff? Just throw it on the ground?
Throw it between the rails.
Oh, they want you to throw it between them?
Absolutely. Why? Why do you think? Why between the rails?
I would think out to the side.
Well, if it's on the side of the,
They want you to throw it between the rails, and the reason is because you're not supposed to be in there anyway. Meaning walking. We're not supposed to be walking down the center of the rails. You can get run over, right?
Yeah.
That's why they want you to throw it in the center, because you're not supposed to be walking in there anyway. They don't want you throwing it off to the side because that's where you walk. So they don't want you to create a tripping hazard. You'll see that a lot too. And you'll just see normal employees out there doing their job throughout the day. A big problem we have is water bottles. Railroaders are the most wasteful people you'll ever see. The railroads supply all this nice water, and it's kind of like a rental car. Anybody ever rented a car? You don't treat it quite the way you do your own, do you? Right. And we feel that way about railroad water too. We're like, let me get a case of that, and you might drink 2 bottles and leave 3 6-packs laying on the ground somewhere. You know, we don't care. We didn't buy it. You know, that's kind of the mentality. Anyway, you'll see water bottles laying there for us sometimes. Guy out there on a switch job, he's out there switching, and you'll just see him sometimes. They'll see something, they'll reach down, pick it up, and throw it between the rails in the yard. And that's what we're supposed to do. Tripping hazards. All right. Different bearing sizes. Cars have bearings, and sometimes those bearings get overheated, and that's what could cause you to have like a hot bearing or a hot journal when you go over a detector. Okay? So not only do you need to tell mechanical folks what wheel number you're talking about, you have to tell them what size the bearing is too, so they can bring the right size. Okay? And it's really simple, right here. When you look at the wheel, it's stamped right on the side. You can't miss it. Okay? So just say, you know, something like, yeah, it's going to be on the R2 bearing. The bearing size is 6.5 by 12. They just write that information down and they got it. Okay, real simple.
do we need to know these measurements? Or?
No, not at all. All right. I do want to kind of explain something to you a little bit. When I talk about identifying wheels on your train, the R2, L3, all those, right? That has nothing to do with the car that's in your train as you're pulling the train. It only has to do with that individual car. Does that make sense? So the only time it's necessary to count the axles or identify a specific bearing on the car is when it has to do with that specific car. Okay. A lot of people want to try to identify BNs and ANs of cars on the train when it's a part of the train. It's not necessary. The only time we're worried about the B end of a car is when it concerns just that individual car. Okay? Now, axle counts are different. You know, you say R1, R2, R3 for a single car, and then they get confused with axle counts over the detector. That has nothing to do with counting the bearings of an individual car. Because you're going to hear axle 282, you know, and the first question I get from students is, I thought they didn't give that stuff to us in three, you know, more than one digit. That has nothing to do with counting, identifying wheels and bearings. Okay. Where that comes into play is after you go over that detector and you get a hot bearing and you have to set that car out, now it's no longer part of your train. You have to identify the wheel on that specific car. It has nothing to do with the train. Does that make sense, or did I just confuse the heck out of you? Okay. And then at that point, that's when you're going to identify that B end. B end is going to be the L3 bearing, and the size is 6.5 by 12. Okay.
Is it good old fashioned counting to find 280? Which car we're talking about? Like when you roll over the thing and you have to set it out later, you just have to count pretty much.
You physically count the axles from the first axle, usually the locomotive, all the way back to 200 and whatever it was.
Now, can you do like a roll by and count, or would you most commonly?
Yeah, it's gonna depend on the defect, and we'll have a class Friday on that. But yes, sometimes you can get off the engine and stand right there and have him pull it by you at no more than 10 miles an hour and count the axles. So you can pull that axle up to you. Be careful, because it is extremely easy to lose count on these axles. And if you're off by one axle, you might set the wrong car out, right? So, you know, for me, I just walk down and I count the axles. For some other people, they'll use a counter. You know what I'm talking about, like a little clicker thing? Just count the axles as you go by them. Because it's, I don't know why, but it's extremely easy to lose count, you know? And then you start questioning yourself, dang, is that 284 or 5? You know, and then you're like, uh-oh. So it's tough, you know? All right, car types. We have all kinds of car types, as you can imagine. You've seen it at Argentine. You look across in the tower at the bowl tracks, and you see just a sea of various cars, right? So we're going to just look at some of them. You don't have to remember any of this stuff. It's just to kind of open your eyes a little bit. Box cars, what's that stand for?
KCA, Kansas City Southern.
Kansas City Southern. Okay, another box car. See that right there? What's the problem with that? Doors hanging off. What is that, do you think? It's a reefer, refrigerated box car. See the, that's where the motor is right there, for the air intake. Let's another look at it. That's a temperature gauge right there. That car's got a little bit of an issue.
Spitting out.
He's loading that one up. Different kinds of hopper cars. Okay, Burlington Northern. What's that right there?
That's a defect.
Who?
Bad odor.
No. That's what
It's
it's
not
supposed to be.
That's
Okay. I thought it was-
Stirrup.
Start. Okay.
Stirrup. Okay. That's always the first part of the ladder. Stirrup. And then you got the ladder.
Yeah, no, I
Stirrup. Okay. See how you don't have a stirrup on the end of the car? You're not supposed to get on a car using the end ladder. See the dump doors here? That car's going down the hump. What kind of handbrake is that?
Vertical wheel.
What's that right there?
So, that you're
air reservoirs. Got the emergency auxiliary, right? Another type of hopper car. This is at a industry grain elevator, filling the cars. We won't do this as conductors. Okay, so that's not what we do. That's basically an employee at the specific facility. Okay. Now we'll spot the cars there. You know, we'll set the cars out there, and then when they get all done, we'll pick them back up. Different types of tank cars. We got high pressure cars, low pressure cars. Okay. Cars that have a tendency to spill stuff. You got to watch out for that stuff too. You don't necessarily want a bunch of sulfuric acid spilling out of the top of a car onto you. Okay. And think about it. Some of these cars carry 40,000 gallons. That's a lot of stuff. So that stuff can start sloshing in there, right? And it can, you know, spit out pretty good ways. So you want to be mindful of that. That's more of that rule we had this morning, be alert and attentive, right? Another type, that's a placarded car, you can see that right there. Different kinds of coal cars. Intermodal cars. See right there, the B,
Oh, yeah.
the BN. And you go on down and you see the A. And in between it's CDE or whatever. Articulated, non-articulated.
Articulation. No? Wait, no. Since connected.
They won't share.
They do not share, so what is it? Non-articulated, right? It's still one car. See the solid drawbar?
Oh.
Okay, so it's a non-articulated multi-platform car. Right there. We call these piggybacks. Okay, you can see the difference. These are containers. These are trailers. That's a full-blown semi-trailer. Truck can hook up to it and go, right? You have to put these on the chassis, okay? That's what they mean in your book on that one table, containers, trailers. That's what they're talking about. Yeah.
Are they double stack trailers?
Mm-mm. No. This is a, they call them spine cars. They're intermodal cars. And they just stack the container instead of a wheel. Now putting it in a wheel of a car, it affixes to the top of the car. And these can be double stacked too. You see what holds a container on right there. Heck, they can even put tanks in intermodal service. Specially outfitted bracing and whatnot. Gondolas, these are what we call coil cars. There was some of them going over the hump yesterday. I didn't know if you saw those or not. Extremely heavy car too, I would add, with all that steel on it. Log car. That's a gondola. It's got lead plates in it. Probably pretty heavy. See these cars? It's got the ends that are up on them. They call those bulkhead flats. They're pretty good cars to use for like shiftable loads. Like you got to load a pipe to keep that pipe from going back and forth. That's a good car to put that on. Like that. That lumber, it can't slide forward. And that's a bulkhead flat too, you just can't see it because of the shadow. Like so.
Will they normally have two ends, or will it just be like?
It'll be two.
It will be too.
Yeah, both ends are the bulkhead. Customer's facility, probably a lumber facility. Can we help you?
I have a ladder needed for 104 here.
Yeah, we'll, yeah, can we have just a second?
Yes, sir.
All right. This is just a flat car, and it's got panels of rail on it. That's all it is. Same thing, customer's facility. Did you guys see any Boeing cars?
We
They were
suggested
empty.
they were empty.
They were
Okay.
empty this week.
Fuselage cars? That's what that is without the covers on. That's what one looks like.
So, wow, really.
Yeah, this is specialty type equipment. Some companies will ship that stuff, big transformers and stuff.
How wide of a load can you have?
It all depends on the route that it's gonna go. I've had one up to 13.6 or something like that.
Like past the
Oh, yeah.
rail
It's no, it's from the, you know,
from this.
it's total, but it would overhang the rail by,
6 or 7 or
5 feet maybe.
And that's something definitely let your train dispatcher know?
well, he would.
You have to let it know, yeah. And it has to be cleared. You're gonna have a track bulletin that covers that car also, because other trains need to know that that car's out there. See anything wrong with that picture?
Chains are loose.
Loose chain, see it?
Now,
So
whose
that's-
responsibility is that to tighten that up?
Carman,
Carmen?
all right. Now, it's gonna be your responsibility to report it. That's an auto rack. They carry automobiles in them. That's an auto rack, doors are open. Different damage. Got some flour or something leaking out of there. That's been handled a little rough.
Yeah.
Sometimes that's not the crew's fault either. Sometimes the structures just give over time. Door, probably the contents slid back and knocked the doors open.
Hey, free stuff.
That's what
I mean,
happened.
not free stuff.
Got a log sticking way up in the air there. Shifted load, come off the side, see it?
Now, that log could have caused some problems. Do you stop for that?
If you happen to see something like that, yeah, you need to stop and do something, and you're probably gonna set the car out. Because if you go under,
Bridge.
yeah,
That's why I was thinking, like
Yeah.
a bridge or something.
yeah,
But
some,
what happens if there's no place to set the car out?
there'll be a place, there's always a place to set a car out.
Okay.
You might have to move up a mile or two, but you can always find a place to set a car out.
Okay.
It doesn't mean that you have to set it out right there at that spot. You just gotta get to a place to where you can set it out.
Okay.
This is a mess, you got a shifted load on both sides hanging off.
Sorry about this. That log, would you be authorized for reverse movement?
What do you mean? If you had to go back somewhere and set it out?
Yes.
Yeah, you'd have to talk to the train dispatcher,
Okay.
yeah.
Oh,
No
That's seen
problem
better
there.
days.
That's just a derailment. Back wall.
Yeah.
Is that upside
Thank
down
you.
or?
Yeah, it's upside down. Shifted load, buckled the doors. Another shifted load. Different types of locomotives. That's a Cadillac. Air conditioning, refrigerator, captain's chairs, desk. Nice.
desktop.
Yeah,
I think you spend your seniority on.
yeah. That was a Cadillac back in its day.
How they look pink.
Uh,
I saw a few of
That's
those.
little work engines, kind of what we use out in the field here. A lot of locals use them, industry jobs. Not quite as nice as the Cadillac.
No air conditioning?
A lot of times they got air conditioning.
Switcher?
That's a big old CSX switcher. That's a little bit older switcher. That's a lot older.
Yeah.
That was before its time,
Wow.
aerodynamic,
That
right?
looks good.
And then you could have rocket assist.
Aren't those things pointed backwards though?
I don't know, if that's the head end of it, I guess it's not.
Okay, yeah. I
You know what I'm
guess-
saying?
Okay, yeah.
Oh, that could be
If
like,
that's the ass.
Well, somebody was thinking futuristic there, wasn't it? And that's the old National Academy of Railroad Scientists engine. And that's a freight car.